Some people have problems with this. This is volumes. And in this case, in order to find the surface area of a pyramid, you have to use a slant height. And in this case, the slant height is not given to you, but you can derive it from what you are given, which is the regular height is 20 centimeters, the radius is 9 centimeters, and if you look at this as a right triangle, that hypotenuse, which is the slant height, is right here, this line here. I'm going to pull it out of here and isolate it. So this is 20, that's 9, and we get 20 squared plus 9 squared using Pythagorean theorem, which is 400 plus 81 equals c squared, let's call it. And so we get c is equal to square root of 481. That's our slant height, which happens to be 21.3. And that's what we need to use in our formula for surface area, which is given to us here. I'm going to zoom in on that now. Our formula for surface area, it's two different ways, pi RL plus pi r squared. But you can factor the pi r and look at it this way if you want. Pi r times L plus r. We'll use the first one up top and just plug it in, and it's pi. The radius is 9. The slant height is 21.3. And then plus pi r squared. So pi r squared in this case is pi times 9 squared. That's going to be 81 pi. And when we work all this out, we end up with 81 pi. We're going to end up with, I'm not going to do all the brutal calculations here, but we're going to end up with something approximately 278.4 pi. So approximately 278.4 pi. And that's just taking the 81 pi and adding it to this, which is about, I don't know, 188 point something pi, and then we add them together with 278.4 pi. The key to this question, though, is recognizing the slant height and actually being able to derive it when you're not given it to it directly, but you're given something that gives you almost that. The Pythagorean theorem helps you find the hypotenuse, which is the slant height of this pyramid, and then you plug it into the surface area formula. So look out for those ones. They're kind of tricky. Make sure you're using the slant height.